Okay, welcome to the Bucky call of 9:14, 9:15, depending on which continent you're on. Joe is at an event tonight, and John said he would not be here tonight, so it's the three of us, and anybody who's watching the video is welcome to do so. We're starting tonight on page 11 of the Amy Edmondson book, A Fuller Explanation, which is really cool that she uses the pun on the name Fuller. That's
Yeah.
exciting. Um,
Yeah.
And so here we go. Richard, how are you feeling, and what do you anticipate to get from tonight?
Well, I'm feeling pretty good actually, and I've had a good session this morning with the TrimTab group, and we had one of the founder developers of the Zoom tool demonstrating how that particular set of structures of nodes and connectors can be been used to build all kinds of well, basically sacred geometry kind of structures. So um, it's really quite fascinating. Um, yeah, and so I mean, again, what I want out of tonight is really a continuation of a revisit with Amy Edmondson's book and trying to integrate more of her practical explanations or translations of some of Fuller's deepest sort of thinking and and language that sometimes is so omnidirectional that it overwhelms in the first sort of glance at the words. And this kind of dialogue for me is very helpful because it helps us slow down some of that fast thinking and fast talking of Fuller if we were actually trying to learn from his own voice and words. So between between Amy Edmondson's writing on Fuller explanation and our own way of working through each of the pages and and chapters is really a blessing, really, in terms of being able to learn at our pace, along with the pace, in this case, of Amy writing what she's been writing or what she wrote years ago. So, how are you feeling, Anne? And what's your interest in takeaway today?
Actually, I got a lot just now from the talk we had, the discussion we had earlier, and then what you said about about Fuller being the way he talks about life and science and the world around, the principles, the universe, is fast paced, right? It's fast paced, and it's true. It feels so fast paced, but we are doing it slowly, you know. So it's such an oxymoron there. Very fast paced up here, and but then we took a lot of time to move at his fast paced, yeah, a fast pace. So now the for Amy Edmondson, right? I like the fact that we are going through Fuller again, yeah, Fuller again, and yet I think each of us are getting, every one of us, we're getting so much out of it, yeah. And it's like going through like the whole field of our discussions. And because when I started taking notes again, at one point I couldn't quite take as much when we dealt with the facts, but with this book, we're back to, oh my God, there's so much to pick out, that even though we gone through the thing, the Bucky's book, but having this maybe another perspective to it and bringing it, let me see how, okay, maybe the best way to try and put it is this. I find that dealing with Bucky's book and his words directly is like I have to access the neocortex, I think our intellectual brain, right? Okay. So I feel like I have to access that at 100% of the time when we deal with this book. Whereas with Amy Edmondson's, it's like we are moving back and forth. Okay, we're moving back and forth from neocortex to mammalian brain and even to reptilian brain, and it's very comfortable. Because I'm trying to figure out, as you were talking, yeah, Richard, what is it that's different between Amy's book and Bucky's book, or Bucky's writing, yeah? I think that comfort of being able to move up and down, back and forth, which is for many of us. Some actually they function the reptilian brain. And there are others, I've met students and even adults that function purely from the neocortex, It's really interesting to watch. The ones from neocortex, some of my students have seen, they calculate every relationship and every interaction. You can literally see it in their eyes, because the decisions they make, you can see is very much, you remove the human interaction, the human spirit part of it. Very, very interesting to watch. So yeah, really looking forward to where else we're going to go and how much further we can take. And I think the book is taking me very, very, very far. Okay, so Steve, how do you feel, and what do you expect to take away today?
Well, I would mirror exactly what you just said about how this book is taking me very far. I'm looking back at some of these other notes, and I get confused as to whether I'm getting the insights from Wednesday or from Saturday, or from this book, or where I'm getting it from. But I have to agree with you that one of the quotes that we learned in these calls is that Bucky decided one day that he'd rather be not understood than misunderstood. And I think that's one reason why people are up, he blows my brain. And I'm really grateful for in this book. And here's the crazy part, is that I had so many epiphanies from last week. I made notes on the side of the book over here, on that last page 79. Plus, I made a note, and I've probably done about 3 or 4 pages of dictation to myself over just insight of different aspects, including this, what I call extreme speech, where I want to talk about words. And he points out that there are no solids. This is what we discussed last week. There are no solids. There are no things in the universe. There are only events. And that blows my mind. I mean, some people, well, what do you mean? The Empire State Building is solid. Well, give it 1,000 years. Let's see how solid that is, Take anything that you can define and give it enough time, it's no longer solid. And that's, to me, was a big time epiphany as I'm explaining to people that there are no solids, that ultimately there are no solids. Everything is energy. Everything comes into material existence and then goes out of material existence. We can talk about entropy, or laws of thermodynamics. And Bucky seems to be into the metaphysics of all that, and like, how is that all being structured? I've got 3 or 4 things that popped up in my head while I was talking about that, but I don't want to ramble on too much. It's just very, very powerful experience that I'm having with this book, and you guys and what you are adding to it from each of your paradigms is so significant. So I'm just really thrilled. And with that, we'll excuse the others that aren't present. We'll go ahead and start. We're continuing with this section called Experimental Evidence. And we'll continue to read from there at the top of that page 11. And I like rotating around on the reading. It gives me a chance to practice seeing how I can read and be intelligible, and then it gives me practice listening to others. So I'll start for paragraph 2, and then we can rotate around if you like. And if you don't want to read, just say, I pass. And that's all you need to say, no reasons. Instead of dimensionless point, oh my gosh, this was a big time epiphany for me, you guys. Because in the past, whenever I've talked about dimensions, every lesson on dimensions say we start with a point. It doesn't exist. Well, what came up to me was the point is infinite. It
Yeah.
doesn't mean that it doesn't exist. It just means I can't measure it. And if it's infinitely small, then probably it doesn't exist because it's so small and micro, it's irrelevant. But if it's infinitely big, I can measure it up to a point. And that was a big time epiphany for me. So instead of a dimensionless point, Fuller proposes the widely applicable energy event. Every identifiable experience is an energy event. He summarizes, and many are small enough to be considered points, such as a small deposit of chalk dust. An aggregate of events too distant to be differentiated from one another can also be treated as a point. This goes right along with what I was just saying in my little share. Too bad I didn't read this. I'm going to circle this right now in the book. Consider, for example, a plastic bag of oranges carried by a pedestrian and viewed from the top of the Empire State Building. Wow, it even mentions the Empire State Building, which I just brought up. Or a star consisting of an immense number of speeding particles, apparently as a tiny dot of negligible size, despite having an actual diameter far greater than that of Earth. That's pretty cool. And I'm ready to pass it on to somebody else and just swap off every paragraph or just read until you're no longer comfortable. Who knows they're next? And I'd love to hear from you because you're going to be leaving early and it'll just be me and Rich talking to each other.
Okay, Richard may have to take it on first. I don't know if my in-laws are half an hour early. Just give me a minute.
Okay, good. You aren't seeing the screen? Okay.
Yeah, the guardhouse just called, so I'll be back shortly. Let me just see who's.
Okay, really good. Richard, do you want to go or shall I read one more?
No, I can go ahead.
Okay, good.
The mathematician's straight line, defined as having lengths but no widths, simply cannot be demonstrated. All physical lines upon closer inspection are actually wavelengths or fragmented trajectories, even a line of sight. Even a line of sight is a wave phenomena, insists Fuller. Physics has found no straight lines. But forces exist and they all push or pull in a line which can be modeled by a vector. So Bucky proposes that we replace the word line with vector. Finally, the continuous plane with no thickness must be replaced by a mesh of energy events, interrelated by fine networks of tiny vectors. To Fuller, these adjustments were crucial for mathematicians' games with continuous planes and sizeless points were ultimately irrelevant diversions. However enticing the intellectual pursuit might be, they do not help us understand how nature works.
Beautiful. And Richard, you made this point last week on one of the calls that there are no lines, that are only vectors. And I'm really taking a look at that because it seems to me, and I don't know if you guys know this, but when Elon Musk started developing his self-driving cars, they tried all sorts of optical things with pictures and things. And they had to throw away all of that work because what Elon and his crew came to was there are no things, there are only vectors. And so his software works off the vector principle. So every image is converted to vectors based on its size and its motion. And, I like to say, I've said to people, well, I'm pulling up to an intersection. There's a giant building and there's a giant truck. Which one am I going to pay more attention to? Probably the truck because it can move. I'm just going to want to avoid the building. It's relatively stationary vectors, but that truck could get up and go at any time. And I think this idea of considering reality as just vectors is very, very profound.
Well,
and you brought that up last week. Go ahead, Ricky.
Well, no, as I say, along that line, the sentence that really jumps out at me right now is the one that starts with finally the continuous plane, but then he goes on, says it must be replaced by a mesh,
Yeah.
a mesh of energy events. So those are kind of the nodes where we often call things, but a mesh really sounds mushy.
Yeah.
And interrelated by fine networks of tiny vectors.
Yeah.
So this is the whole thing, that what often I think appears solid is a mesh of energy events interrelated by fine networks of tiny vectors.
Yeah.
Um,
Beautiful.
and and so I'm coming to grips with the notion of energy events and vectors and networks. But the mesh of energy events, really, that word somehow or another jumps out at me in terms of what mesh means. And it really is like a net or uh, uh, a spider web, maybe.
Yeah.
But it's that mesh of energy events and vectors, which is really a mesh of intensegrity, a mesh of compression and tension. And in a network, it's a mesh of what we often refer to as nodes and connections.
Yeah.
And then it's not going to take very long before one can go from that kind of statement into the mathematics of how do you if you want, measure the complexity of the mesh. And to me, that formula, the n squared one, will, if we can figure out, how many energy events there are,
Yeah.
then we can figure out how many interrelated fine networks of tiny vectors there are between these energy events. And that's where you really helped me last week or a week before in understanding the way in which you count the mesh in a hypergraph. Because in some ways, I think the thickness must be replaced by a mesh of energy events interrelated by fine networks of tiny vectors is also the definition of a hypergraph,
Yeah.
where all these little nodes or energy events are interconnected with each other.
And I like the word mesh particularly because network, I don't know, a mesh seems to me to have a feeling of more than just two-dimensional.
Yeah.
I think of a stack of gauze as a mesh, and it's easy for me to see a 3D mesh. I wouldn't think of a mesh as a 2D entity.
Mm.
Maybe it's just me, but it seems to be mesh is 3D. And one more thing, Richard, I don't want to interrupt you, but you brought out it's how many energy events, I think you said, are known. But if we bring in the Bucky terminology, it's how many events are deemed relevant by the observer, because some events could be so small they become tantalizingly irrelevant because they're too micro, and some events are so large they become tantalizingly irrelevant because they're too large to be calibrated or measured. So, and
Yeah,
I
well,
just
that's what I'm getting at, I think, is that
yeah,
the counting of the energy events has its own limits in the sense of
yes. And so
so
if
even
I
if you count a certain number and then use the formula to decide how many interconnections there are,
yeah,
you may not have counted all the energy events
that's right.
because you say you're trying to count those that are relevant, and often what's relevant is what's visible.
Yes.
And so there's a bit further on, or maybe it was another page I was reading, that really gets into why Fuller is so big on the importance of modeling, modelability,
Yeah.
because he's saying that so many things now, so many of these energy events and vectors are invisible, that we need models to represent the well, to give visibility to the invisible. And I don't think that's caught on yet, because I think many people shy away from the idea of an actual physical model, like a tetrahedron, for example, or any number of other geometric kind of structures. They don't fully realize that these are models that help us visualize the invisible. And since, if he's correct, he's arguing that 99% of what we're experiencing today is by and large invisible.
Yeah. And I just think I'm going to promote this here. Anna's dealing with students. If I were a student, and I'll tell you, for me, I'm getting more and more addicted or more and more accepting of the idea of saying sun sight and sun clips, in spite of the social reaction I might receive, because the way it affects my brain. It steps me out of the trance of what is obviously observable, and I'm ignoring it. And the same thing with, if I were a student and I no longer said the word lines, but talked about vectors, and I no longer talked about what was known, but talked about what was deemed observable. So that if I were writing software and I'm limited by these events that I want to call things, if I'm limited to that, I'm going to struggle in my software writing to break into whatever realm of there is. But if I'm already open to the idea that there are no lines, there are only vectors, there are no events, there are only things, and I mean, there are no things, there are only events that I am able to calibrate and measure using a certain set of tools. What if I used other set of tools? And if that were a conversation going on in my head as a scientist, as an observer, as a student, as a computer programmer, I might not be so much in the box.
Okay. Just now, Steve, you said, no, not events, only things. And then what was it? But observable.
There are no things. There are no things. There are only events. That's
events.
That's on page 79. They're energy events. Yeah.
So the one about observable.
I just am constructing that from my sensibilities about his circles, or what I call them now, the spheres of irrelevancies. And remember, in the spheres of irrelevancy, there's what is observed, and then there's right around the edges that which is tantalizingly irrelevant. In other words, it's close, but I'm not going to see it. And I can show you that diagram very quickly.
Okay. I think I have to listen back, because I like the way you said it, because it's just very, very point on. You said no, instead of not events, but we don't call it events, only not it's only events and not things, right? That was what you said. Yeah. And then there was something else, not this, but observable. Is it? It's not invisible, but or relevant. Which wait a minute, I'll go back.
If it's invisible, I tend to think it's irrelevant. I tend to think it doesn't exist. But if I can move into a paradigm where I said, well, I'm not seeing it, but that doesn't mean it's not there.
Okay. No, it's just the way you said it. I lost it. Okay. Then I'll listen back.
Listen, anyway, I took this transcript from last week's thing, and I wrote it out, and I've got 13 pages. I'm reading through it just like you're saying, because it's just so powerful. And if you want, I will send you the transcript.
Oh, okay. Yeah, okay. I think you normally do put it out for us anyway. Yeah. Okay. I just wanted to share this. The last meeting I had with my heads, right? This is a bigger group, and I brought up a couple of the things that we discussed. So one of the things was what this Joe was saying about logic in relation to reality. So I said I love that, because it came from the Stoic retreat, right? And then because now I said I was giving an example, because there's so many people, especially making decisions and conclusions, assumptions, and it's not based on reality, right? So case in point was economics, for instance, and they're not basing it on the reality at all. the scientific facts, in fact, right, or the universal principles. So I've been every meeting or so, I've been bringing these whatever I've been picking up from our meetings into the meeting. So the one in relation to reality, so I started giving them the reality, because I got a lot of my science people who are so rigid in how they look at they're some of the worst when it comes to coming up with the link to reality and no, the link to the human life to life, right? So some of the decisions they made have really created like we had to deal with parents and so on and so forth, right? But my point is, so I shared with them about the 99.99% invisible, that the world is that, and a few other things that came up from our discussions, right? So that's what we've been, and I just want to share, it is a nightmare trying to put this and make it the main, like the whole focus of the overarching principles of the education system that we are creating, right? So it's a whole nightmare. For us, we can create the content and the curriculum, and we can take it high. And for us, we come from that space when we're creating the content, etc. However, to hire the people to help us grow the education system, that is where the nightmare begins. Okay, yeah. So in Asia, imagine we have to get it right for children, and the reason why we went down to creating a kindergarten curriculum was because it was oversimplified and dumbed down, so severely dumbed down for kindergarten children. And bear in mind, in Asia, a lot of the kindergarten teachers their education system is maybe up to or level is maybe up to high school, and people deem that you can teach kids, right? And we're not. We have degree holders to take it, and people who really know math and sciences, but even then they don't know what we're discussing today, right? So the nightmare begins because right now the schools that we're opening in Indonesia, and we will be opening more in KL, the nightmare are the training the teachers, because fundamentally where they come from is so stuck with the information that's already irrelevant. Basic things like even basic things like how the world, the people are worried about the environmental side and nature and things like this, and we're not even looking at the correct problems. The problems in the correct let me rephrase it, in a manner that is what nature really is. Right. Okay, or the universe, or the cosmos really is, right? So and I've been putting in, and you'll be happy to know my hits and some of them are starting to use like cosmic integrity. It's really interesting. Wonderful. And my econs people really now got the thing about the resources, management of resources rather than management of scarce resources. But we have to, and again, bear in mind, we have to caution the kids on what they say in their essays, in the exams.
Yeah.
They have to give. So this is a huge education nightmare.
It is a nightmare.
It is a nightmare.
And I just heard a podcast from a guy who teaches at Stanford University. And he was being interviewed by some guy, and it's kind of intellectual, and they're having a conversation, but right at the end, he comes up with a big condemnation of the university system, the educational system in the US. He says right now, the employers are not hiring people from Stanford. They're not hiring from Harvard. They're not hiring from all these big schools because the smaller schools have more valid curriculum. And for example, he talked about climate change and said everybody's about sequestering carbon and getting rid of carbon. Carbon's essential for our existence. And what we want to do is have rotating crops that put carbon back in the soil, because the soil, you're not industrial farming. If you're doing regenerative farming, you're putting carbon back into the soil. So eliminating carbon is not the problem. And that's the whole woke current political thing, get rid of the carbon. And if you say, oh no, we don't want to get rid of carbon, you can be canceled. Because
Yes.
people are not being realistic about the natural world. Right?
And Steve, my God, what you're saying so resonates, right? Because we are actually working. My partners in Indonesia and Singapore, as I mentioned, we are working on the replacement system, right? Julian,
Yeah,
coming in.
isn't
Yeah,
that
so
exciting?
yeah, so the thing now is you're absolutely right, and because a lot of the universities, that's current. Hi, Julian, good to see you. Oh, it's been a while. Oh, you can't hear. Okay, so anyway, a lot of why people are
Hello, my
not
friends.
hiring. Hello. Hi, Julian.
Hi, Anne. Hi, Steve.
Welcome.
Sorry for in the middle. Hi, Richard.
Yeah, you're welcome.
How are you doing? Keep
Yeah, we're all
doing your
good.
thing. I'm going to a glass of water and clean my glasses and be right back.
Okay, good.
Okay, all right. Yeah, so where was I? Yeah, so the what he said is absolutely true. People are not hiring from less. And this is the first for me to hear. I already knew that many are not hiring from universities, right? And there's some universities or colleges or even schools are really standing up. People are hiring directly, even from high school, like the San Diego High Tech High. I visited that school a number of years back. And so places like this, right, they go direct. And there's a reason actually for it, even for us. The traditional ones, and I thought it'll be a while before what you said was going to be observed or mentioned, right? So for a Stanford, someone from Stanford to say it so recently, right? That's crazy because they're not hiring from Harvard, they're not hiring from Stanford. I already knew that from a talk. I went for an EdTech conference in Vietnam, and there was a speaker. He was from one of the big Swiss banks, right? I'm not mentioning names because I know this is going to go on the internet. So he's from the UK but based in Hong Kong, right? And he said that even their company, they're no longer hiring from Harvard. They said that, right? They said that. And I was like, whoa, not even from Harvard, right? I know that the regular universities are traditional. They're really losing the value, right? And people say that they're coming out, they're graduating, but the value is very low. But for it to come out now, like even from Stanford and so on, that's crazy. And there is a reason why they would hire from some of the new ones, because the newer ones came up because they didn't agree with something. Yeah. And these are people who, like us, what happened with our education system, we created because we didn't agree with the traditional ones, right? So right now, when people make decisions, we are one out of the 5 schools that people would look into before they make a decision. And I realized that these 4, because they're developers and also one of the financial, they came from a financial system background, institution background. These 4, they already have their brand, and the developers have captive audience in their development, right? So they don't need to change. So we're the only one that's changing because we're not developers and we don't have no captive market, right? Or branding from the past. So, and we're the only one changing. So the same thing is happening in the colleges and universities, because there's one in, I can't recall, I know it's on the west coast of the US, one college or university that's very popular with the companies in Silicon Valley. They'll go direct there and hire them. Very, very in demand, So what you're saying is absolutely true. And so I'm just sharing here that the nightmare, like right now, the talk is at that level. It's not reaching ground level. Yeah. It's really, really not reaching ground level. And the change needs to happen. Like the parents need to know this in terminology that, or this explanations that they get, they can understand. It needs to go, like the teachers, the kindergarten teachers need to know. So even right now, we change out the kindergarten, and there are certain things we make sure that the kids are learning it as a fact. Did I ask you what is a tomato before? I did
What?
ask that before, right? What is a tomato?
Oh, yeah, you did.
Yeah. So that
What is that?
alone needs to
I haven't
change.
heard that before.
Yeah. That
What's
alone,
about
that's
what's a tomato?
yeah, what's so technically a lot of us learn it from kindergarten and primary school at the vegetable. Same thing with cucumber and this aubergine or brinjals and all that, right? Chili is another one. We learn it as a vegetable, but they're all fruits. They're all fruits, you know. And the thing is that so that there are a lot of facts being taught in kindergarten that's incorrect. It's incorrect. They're not facts. Yeah.
True,
So
true.
Well, this isn't it all. This is always what troubled me is that carbon is considered the essence of life.
mm,
Yeah.
So we're saying we're carbon capturing, but what we've done is shorthanded what we're capturing. We're not capturing carbon.
Yeah.
We're capturing carbon dioxide.
Right.
yes.
And unless it's almost like sunset and sunrise. If you don't use the right word
Yeah.
about what it is you're doing, then you send out misunderstanding messages about what it is that's being removed.
Absolutely.
Makes total sense.
And so I find that's the same thing with what we were just talking about in terms of energy events and vectors. And in a modeling way, they actually capture the principles
Mm.
of energy events and vectors, and so they can apply to a physical system, but they also can apply in a metaphysical way. And in order to understand it metaphysically, one can use geometric models to give visibility to it.
Right.
So to understand the basic structure of a tetrahedron, if you want, or the carbon molecule, you can create little stick figures that explain that the edges are actually vectors, and those vectors can be long or short. And so when you
curved, they can be curved, they can be
and they
wavy.
can be curved, and they're wavy. And so again, when you try and explain the energy event of the four of us and the vectors between us, then you can actually begin to get an idea that the vector in this visual feels like it's sort of reachable. I can reach out. But if I looked at the vector in a geographic sense, then the vector between me and Anne is 1,000 miles or kilometers, and the same with Steve and all of us, Julian as well. So so you end up with a different understanding of how close or how far apart we are vector wise. Yeah.
Okay, Julian, I am muting your phone because when you unmute your audio, there's an echo. So I'm happy to have you turn on your audio when you're ready to talk, or maybe raise your hand, and then I'll solve that problem for you. Okay? Do you want to say something right now?
So it sounds good. Sounds good, Steve. And thank you for letting me know, because I'm not aware when there's feedback or echo. I was asking Richard if you're trying to explain vectors for children. Is that what you were trying to explain? Because Anne was trying to explain tomato to children, right? Like, it is a fruit or it is a vegetable. By the way, the correct answer is that it is a fruit.
Yeah, I checked this out from last
Okay.
week. If you look it up, it'll actually list a whole bunch of different fruits that we call vegetables. There are a big giant list of them. It blew my mind. And Anne brought it up last week. I said, no way. You know, I knew about tomatoes, but I didn't know about all the others.
We don't think of it. Actually, it's the definition. The definition is anything carrying seeds. Not one seed, no, seeds. Those that are, yeah. Oh yeah, active seeds, whether it's one or many, because Anyway, I'm gonna have to go.
Man, if you have just 30 seconds, I'd like to show you something before you go.
I'm learning so much. I didn't know that the fruits were for the seeds. That makes total.
I want to show you guys something, Anne, very quickly. This is our invitation.
Sure, go ahead.
Right here. This is the invitation from last week. Oh,
Okay.
Fred, I didn't mean to do that. Hang on. I'm going to show you something that most people do not know. So I'm clicking on the invitation. Up it opens up. I come down here. I find the video. Here's the recording for the last week. I'm going to plug that in. It's going to redirect me to that. I'm going to show you how to get the transcript. This is so easy to do. So you come down here to, this is our event from last week. Hang on, it's got to load in. I've got to see the text down here below. I'm so sorry to detain you. Good, there we are.
No, that's okay.
Okay, come down here and we click the more button. And then you come down here and it says transcript. Show transcript. You click right there, and what happens is it opens up off to the left side here.
And now you can do the search.
Now you can see the words. You can do a word search for keywords. And you can toggle the timestamps on and off. So if you put the timestamps on, now you can go down here. Let me see. Look at the timestamps on. Okay, good. Now, if I know that it was somewhere around a half an hour in, I can come down to a half an hour and I can go click right there, and automatically it moves to 53 minutes in. And this is making a sound, so it's making confusing. All right, and you can do a word search. So I can go over here, and I think I can go, let me see here. What I do for sure, what I do is I just take the whole thing and I paste it into a Word document or into a note document. Yeah. And then it's easy for me to do word searches. But there, now you have a transcript of exactly what was said in that particular segment.
Wow.
Also now you can summarize. You can have summaries.
Yeah.
It is not with, it is not supported with YouTube, but you can use external platforms to.
What I do is I come over here and I start at 0 and I just drag it down and I get the whole freaking thing down here. Come on. And then I right click and I paste it into a Word document or into a notepad.
Wow.
And so I go right click, copy,
summary.
And then, and I actually do this. Last week I did this because our conversation was so valuable to me that I needed to have exactly what Anne said and exactly what Joe said and exactly what Richard said and even what I said, right? And my machine's a little loaded up right now, but I'm loading a Word document. There it comes.
Thank you.
2010. Maybe it's loaded because you're using a 2010 Word.
No, it's because I have 10% of my memory available on my computer, and because I have 2010, 2013, both versions on, and they fight with each other. But once they open, then I get to use them in really good shape. So I cancel that because it's already loaded. Hang on. There we go. And one more button I get to click. There it is. It cancels. And now up will load my Word document. Then all I have to do is click into that Word document, right click and paste. I'm going to show it to you because it turns out
we have been like 10 minutes waiting for Windows installer.
I'm sorry. It'll come up pretty fast now. I should have had a Word document ready to go for you.
I'm just being silly with you.
No, you're just there we go. So now I got this Word document. So then I come up here, I right click, and I like to paste because I have my documents formatted. So I right click and there it is, paste it into my document with timestamp.
Wow, that's crazy. Thank you.
Yeah.
Okay, I'll check it out.
All right, good. And then if you want the transcript, I actually store them every week. I store the text out separately. If you need a transcript for a particular day and you don't want to go through that trouble of formatting, just send me the date and I'll send you the transcript.
Don't worry. Steve, you have already done so much for us. Seriously, don't. We are really spoiled here. Very,
You're
very
very
small. So
objective.
I'll do it. I'll do it. Okay.
Mhm.
Thank
All
you
right.
so much.
Have a
All
great
right.
family dinner.
Yes. Take care. Bye,
Bye.
everyone.
Bye-bye.
Bye, Anne. Have a good day.
Thank you. You
Nice to
too.
see you.
Good evening.
Nice to see you. All right.
Okay, so here we are. We can continue. Richard, I hope that wasn't too upsetting. I appreciated every point you made. Is there anything you want to summarize here? Because
No,
you know what? I actually have a challenge for you, Richard. What if you took this concept right here about education and reality, created a tetrahedral model, and identified each of the nodes as some part of the conversation, like lines are vectors, and you went through and created a tetrahedral model that
Yeah.
a student could look at that four-pointed thing and say, oh, I got to have lines are vectors, things are events, whatever. I'd have thought maybe if you get an inspiration on it, Richard, let me know, because that would be beautiful.
Well, what comes to my mind right now is that if I went back and used this kind of language and said, what's the minimum sort of kind of coordinate structure of nature, and I know from Bucky's literature that it's got to be 4, and I know that thinking about something like carbon, I know that it has the molecular structure of a tetrahedron.
Yeah.
But what this has really helped me with is to start out with, there are energy events and there are vectors and they can be interconnected.
There's your minimum 2 right there.
Yeah. And so then once I put 4 energy events with 6 vector connections, I've got myself a model or a visible tetrahedron. Then going back to my work in the sociology kind of field, I then had to think of other names that represented energy events. And so I ended up saying one energy event is the cultural values that we have. A second energy event is the individual, him or herself. The third one is what Bucky would call personal otherness. In other words, personal otherness is what we often talk about as family and friends and people who are close to us. And then their fourth energy event can be named as societal institutions or resources. And so now I've got a minimum 4 that has the language of my discipline. And that's when my story of the engineer on the airplane is that I'm now saying we can strip that information off of that tetrahedron, which can be metaphysical or physical, because I can have a picture of it in my head once I understand it, or I can have a model. So then I can reload it with engineering information, or reload it with music information, or reload it with something else. And I then have an awareness that it all sounds different in the language of an engineer and a social worker and a doctor or whatever. But underneath, the common connection is energy events and vectors. And they're in a modelable form. And that's why Fuller resurrected actually the modeling work of Van Hoof, who got the first Nobel Prize in chemistry because of his modeling of things like tetrahedral structures. It's also It's also how the carbon-60 people made their discovery of carbon-60. It was through models, through a modeling kind of activity that allowed them to sort of see a visible of what they were looking for. Anyway, that's kind of how I'm coming at it now in terms of getting more comfortable with the language of energy event and vectors.
Very cool. Julian, do you have anything to say about all that? Or any of that?
Actually, I was kind of lost, to be honest, Richard. Sorry, I was
Okay.
reaching to my tablet and some water.
You
But I was hearing something about carbon, and then you got me lost. So you can continue, no worries. You can continue, I will catch up.
okay. I want to bring us back to our page, and I want to read those footnotes, and I got this thing all screwed up. I don't know what page I'm on right now. Unfortunately, the page numbers in the PDF file are not conforming to. Okay, there's page 13. So this has to be page 12.
You
There's
can see
page
the number of pages at the right hand. If you see, there's a 40 and a 367 at the right hand.
Yeah. Okay, we're on the right page now. This is page 11. And here's unfortunately, he uses footnote 2. His footnote number 7, her footnote number 7 refers to Philip and Phyllis Morrison and the office of Charles and Ray Eames, the powers of 10. And that relates to that footnote right. Where did it go? I thought I saw 7. Maybe it's up above. Yeah, it is. There it is. Appearing a tiny dot of negligible size, despite having an actual diameter far greater than that of the Earth. So that was from that person. And then here's number 2, which is probably somewhere back in the book, and I'm not going to do it. Footnote number 2 says, these statements were included in many of Fuller's lectures. I'm quoting from memory and from personal notes. So anytime you see footnote number 2, it's quoting from her personal notes. Okay, good. I'm sorry. That's what I did to kind of like get us grounded in the thing. And are we ready to move on? Is there any other comment or question on this so far then?
No, I'm fine with it.
Okay, good.
No, you can continue.
So we end up with understanding how nature works, and we can continue from there. Good. Okay. Julian, we're reading a couple of paragraphs and sharing reading. Do you want to read, or would you rather listen to somebody else?
No, I'll be happy to read.
Okay.
Let's
Start with the essential nature.
Okay. The essential nature of the above revolution is semantic and can easily seem trivial. The difficulty in evaluating the impact of such changes lies in the subtlety of the effect of words and the images they produce. Only through with filler substitutions for some period of time, we judge the merits of the mathematical terminology that reflects science's new understanding of reality. Back to the starting point. Nothing can be accepted as self-evident, and new mathematics must be derived through operational procedure. Filler decided that through sufficient observation of both naturally occurring and experimentally derived phenomena, without reference to a specific framework, nature's own coordinate system might emerge. He sought a body of generalizations describing the way patterns are organized and able to cohere over time. Do you want to stop there and do a check-in?
Just go to the next paragraph.
Okay. We shall
Or
see how
finish the bottom. Yeah.
can be discerned. Okay. How these principles can be discerned, both in deliberate experiments with various materials and by recording existing natural patterns. Bucky's grade school skepticism was thus the beginning of a lifelong search for the nature's coordinate system. After rejecting traditional academia through his dramatic departure from Harvard's freshman class in 1914, he began an independent exploration of mathematics, which he was to pursue for the rest of his life. A sort of philosophical geometry gradually began to take shape, consisting of a rich body of facts and principles, some new and others newly considered. Synergetic geometry is tied together as one cohesive system by the unmistakable presence of Bucky fielder in conventional and bizarre observations alike, including expositions called Tetrahedron Discovers Itself and Universe, Life, Cosmic Hierarchy, Complex of Jitterbugs. What are jitterbugs? And the more conventional, it says Complex of Jitterbugs. I don't know
Yeah.
what's that.
I'll explain what that is. Finish the paragraph, it'd be fine.
Where I was, synergetics. Synergetics does not fall neatly into any preconceived category. It's a new category, the synergetics book. This volume will attempt to clarify these multifaceted or polyhedral observations, which together constitute synergetic geometry.
Okay, cool. I'm going to show you what that is.
Just
It's
while
the
you're
ge-
looking at that last sentence in the word multifaceted,
Yeah,
that to me is also a synonym for multi-energy events.
yeah,
Um,
exactly right. Or polyhedral observations. So if we go to Google and we go to, or we go to YouTube rather, and we look down here, we say, there we go. We say jitterbug, Buckminster Fuller. And I'll put this link in the, this is the jitterbug right here, where he explains the expansion of the universe and contraction.
Okay, that's the one.
Yeah,
I remember that video. That's a jitterbug.
that's the jitterbug, and I'll put it in the chat so you can watch it and you'll know exactly. So anytime you talk about a tetrahedron in so many words, you need to talk about a jitterbug. Let's see how
And the
we.
jitterbug, it's the thing that contracts and expands.
That's right. Goes down to a four bonded triangle and expands out to a cubeoctahedron. And there is the jitterbug.
It's from a tetrahedron to what?
To I said a four bonded triangle to a cube octahedron.
Four bonded triangle to a what?
To a
Tetrahedron?
cube octahedron. I will put it in the chat. I will put it in the chat.
Thank you.
Do you want to comment on that at all, Richard?
well, yeah, my understanding of the jitterbug is you take, it's like a icosahedron in a geometric structure is solid, I mean firm, but you take out, there's a number of struts you take out so it gives it flexibility, and then you have a triangle at the top, and it sits on a triangle, and you push down, and it twists into a octahedron shape, and then you lift it up a bit, and then you torque it, and it folds down into the basic tetrahedron. But you can also then take the sides of the tetrahedron and fold them down into a triangle. And then you can let it go back up and down, almost like an accordion. And that's, so it pushes down, it twists or torques, and it stays firm on the triangle down at the bottom. It can be torqued all the way down to just a triangle and then back up.
See the triangle here at the top?
The jitterbug is the movement. That's why
Yeah.
he called it jitterbug.
There's a triangle at the top, as Richard said, and there's a triangle at the bottom. And then what happens is he pushes down on this triangle, all this interaction occurs in between, and that's called the jitterbug.
That's amazing. Yeah, I remember that video. I remember that it twists. It is really interesting how it twists. Like,
That's right.
never
See the
thought.
triangle on the bottom and the triangle on the top? And then he puts pressure down and it goes through these major tetrahedral or major polyhedral shapes.
Mm-hmm.
Somewhere in the world, there should be an architect who is playing around with this.
There should be a what?
An architect.
Yeah. I've actually got this all scripted out and broke it down so you can read the script because he's very hard to understand in the video. But there he goes. He's pushing down on it, as Richard explained. And it goes through rhomboid shapes. He explains how the pressure goes. This is his jitterbug. And that's where
it is. Yeah, we don't have to see the whole video.
Okay, you see him shrink it down? It goes through these different shapes. That's a octahedron right there.
Octahedron, and there's a double tetrahedron. Yeah.
So anyway, Richard explained it very well in words. And see, he's twisting it now another direction. It goes back down.
What material is that?
So anyway.
Those are just wooden dowels and rubber connectors between the opposite ends.
Got it. Thank you, Richard. Wooden and rubber.
Yeah, wooden and rubber.
And I put that link in the chat, Julian, so you can watch it all you want. And if you want to, send me an email. I'll send you a description with pictures, okay? I think we have time to go off to this next section. Richard, do you want to read?
Yeah.
Yeah, I think we can get through the next 2 pages before we have to go. Let's see if we can. Starting with nature's coordinate system.
Oh, with that title?
Yeah.
Oh, yes, right.
On page 12.
Yeah. So what accounts for the shape similarities among unrelated phenomena? What accounts for the shape similarities among unrelated phenomena? Radically different in both scale and material? Question mark. Or more fundamentally, what accounts for nature's magnificent orderliness itself? Whether honeycomb or conch shell or virus, time after time, individual structures turn out true to form. The fundamental hypothesis behind synergetics and the work of many other pioneers exploring the science of form, structure, is that nature's structuring occurs according to the requirements of minimum energy itself, a function of the interplay between physical forces and spatial constraints. Wait. The role of physical forces, gravity, magnetism, electrical and chemical attractions is clearly important, but what are spatial constraints? We are so used to thinking of space as empty nothingness that the idea of it having specific properties seems absurd. However, as will become increasingly clear from the examples throughout this book, space has shape. The idea is concisely expressed by Arthur Loeb in his introduction to space structures. Space is not a passive vacuum, but has properties that impose powerful constraints on any structure that inhabits it. These constraints are independent of specific interactive forces, hence geometrical in nature. A simple example is the fact that to enclose space with only 4 polygons, these polygons must all be triangles. Nothing else will work no matter how hard you try. The limitation is a function of neither material nor size, but rather of the nature of space. Fuller alludes to this active role when he says natural is what nature permits. When Bucky points out that nature doesn't have to stop everything she's doing and gather the physics or the chemistry or the biology and the mathematics departments to decide how to grow a turnip or build a virus, he has called our attention to the self-organization of natural phenomena. Structuring in nature occurs automatically. Nature has only one department, declares Bucky, one comprehensive coordinating system. How does this self-structuring occur? In the most general terms, according to the path of least resistance, or as stated above, according to the requirements of minimum energy. In short, natural systems automatically find comfortable arrangements which are necessarily a result of the balance between specific forces and inherent spatial properties. When Fuller set out to inventory possible configurations and their formulate generalizations, his exploration was destined to be geometrical in nature. Because of the nature of systems, as we'll learn in Chapter 3, nature's coordinate system is thus a geometry of most economical relationships which govern all structuring. In Fuller's more long-winded words, a geometry composed of a system of interrelated vectors may be discovered that represents the complete family of potential forces, proclivities, and proportional morphous. We shall see how operational procedure...
Teacher, can you repeat after geometric composed, what did you said?
In Fuller's more long-winded words, a geometry composed of a system of interrelated vectors may be discovered that represents the complete family of potential forces, proclivities, and proportional morphous. We shall see how operational procedure produced a geometry of vectors and look at the specific shape of this diagram of potentials in Chapter 7, vector equilibrium, which is a jitterbug, and Chapter 9, isotropic vector matrix. The most notable characteristic of these models is the absence of perpendicularity, absence of 90 degrees.
You got that, Julian? It's absence of 90 degrees. Perpendicularity means 90 degrees.
Yeah.
Okay. All right.
Yeah, but what do you mean if I catch that? I caught that.
What is what?
What do you mean with the question that if I caught that?
You're breaking up.
Maybe I'm talking far. I was asking, what do you mean with if I caught that about the perpendicular, the non-perpendicular?
He says the most notable characteristic of these models is the absence of 90-degree relationships.
Oh, there's an absence of 90 degrees. Okay, I see that.
Okay,
Thank
cool.
you.
And that's really the absence of vertical and horizontal.
So listen, Julian, in order to build a tetrahedron, you got to take those right angle relationships and move them to 60 degrees. And as soon as you move those right angle relationships to 60 degrees, you can create 4 nodes in a 3D picture. You can't put 4 nodes in a 3D picture. One will be floating off someplace. They won't be interrelated. You have to collapse it to 60 degrees. That was the magic of the 60-degree relationship, rather than perpendicular, rather than 90 degrees. Got it? Okay, cool.
Got it. Yeah. No, that's very interesting. Like it's
Oops.
collapsing,
Yeah,
making from 90 degrees to 60 degrees is
that's right. And you can't build a tetrahedron at 90 degrees. You have to put it at 60 degrees to build a tetrahedron. And when you do that, you have a solid 3D structure. You do not.
Well, the is 180 angles. If you add the angles, 60 plus 60 plus 60, you have 180 degrees.
Right?
Yeah, but you also have 180 degrees on the outside of each one of those 60s.
You have 180.
Each
No,
node is 360
you have
degrees.
300. You have 300 on the outside.
300 on the outside. Yeah. So, and most people measure the inside angles. And what we're doing, what I'm inviting, or what he's invited us to do, is to go to a tetrahedron, which is now 4-dimensional. If you build a cube with these magnets, it will fall over. It is not going to stay up because it's wobbly. But if you build a tetrahedron, it's nearly indestructible, because the 60-degree angles make it a basic structure, where a cube is not a basic structure. Got it? Okay.
Yeah, got it. Got it. Thank you. Do you still hear your echo? Let me know if you hear your echo again.
What's that?
Well, I was just going to say,
Yeah.
I had an interesting experience with a tetrahedron that's made up of wooden dowels and elastic connectors. And you can pull it apart and make it look really messy, or you can have it really tightly together, and it looks like a very firm tetrahedron. But I was showing it to a room full of about 60 people, passing it around and asking people to communicate with it, just say anything about what it meant to them. And it got to one person who was really angry for some reason at this kind of modeling. So when I said, so what do you think of the model? And he spontaneously said, I think it's a terrible model that should be destroyed. And right in front of 60 people, I'm the guest speaker. He stepped on the model and crushed it down to the floor. And everybody was horrified that he has just embarrassed the speaker. He has just, in a sense, destroyed the speaker and his modeling. And when he took his foot off, the tetrahedron bounced back into its original shape, which shocked the hell out of him too. And I think it might have changed his mind about the value of this model. And everybody else in the room was relieved that he got his comeuppance.
Yeah.
And
I'm sure that every time you did that presentation from their front, you asked somebody to step on it. Try to.
Yeah, well, I then would arrange the dowels and the elastics in such a way, if somebody did do it, it would probably squish and then bounce back up.
Cool. I love it.
Yeah.
Okay, we left off with we thus, I think. If you want to keep reading, Richard.
Oh, okay. We thus explore Fuller's statement that nature is never operating in perpendicular and parallel directions, but rather convergently and divergently in radial growth patterns. Another important aspect of nature's coordinate system is the existence of rules governing the coherence of structures. What holds its shape? If nothing is self-evident, we can no longer take solids or reliable structures for granted. Then Chapter 5 explains Fuller's investigation into structure and the resulting principles governing the stability of systems. All of this takes a while to sink in. The idea that space has shape is profoundly reorientating. We are so used to conceiving of space as passive emptiness on which we impose desired configurations that an entirely new perception cannot be adopted overnight. Nonetheless, upon further study, this premise begins to feel quite comfortable and necessary, and an all-embracing somethingness influencing structural phenomena. As more specifics are uncovered, this conception, which is at once so elusive and so ordinary, begins to be more and more the latter, more and more ordinary.
Yeah. Any comments or questions? You know, we're making good progress. I think we could continue to read. I'll go ahead and read a couple. Universe. The ultimate manifestation of nature's coordinate system is universe. The ultimate manifestation of nature's coordinate system is universe. Fuller deliberately omits the article from the universe, implies the possible existence of more than one. For the term the universe implies the possible existence of more than one, just as we do not say the God, but rather simply God. Fuller capitalizes universe for the same reason. Universe is everything. It's all there is, or more poetically, universe is all that isn't me and me. Yeah. Universe is all that isn't me, and universe is all that is me. And that's significant because when we get into cosmography, or the cosmology book, he has the 18 me's, and the me symbol is right up there on top with nature, which is
18 means?
yeah, 18 me's.
18, 1/8?
Yeah.
How did he get to 18 means? I
Well,
have got to think why he
because
got to 18.
there are different kinds of me's. So let's do this. Let me see. Oh, it's a hierarchy. The key word here is hierarchy.
Let me take notes on that quote. I love that quote. Universe is all. Let me use a marker. Gosh.
So here's his cosmology chart. Takes a minute to get everything up because it has to think through its problem solving. And I think, oh, I got to change this over to here. And so here is 18 me's. Here's the symbol for me, but then he defines all of the me's. There's the synergetically coordinate sense intellect, exploratory sensor, glimpsor, initiator me. Then there's the mathematical logical me. Then there's the subjective me, my brain and my neuron and my ability to store and retrieve and command. And then there's the memory me, that's sort of, and then there's the biophysical me, the atom and the physics. And then there's the biochemical me, the exploratory chemistry abilities. Anyway, he goes through a whole bunch here.
No kidding. The
In
scientist, the
fact,
cultural tribal, the art.
yeah,
I have a me art. Oh my God.
yeah, and here's
Can
the
you
whole,
share that in the group chat or somewhere?
yeah.
Or in the
Hang
video?
on, let me see what this is. I think this one here is going to bring up the entire hierarchy that goes from,
Man, I want to print that out. That looks so interesting.
yeah, believe
The
me, it's
mute, the communication.
quite.
Oh,
Oh, that's the one that's already out there.
Maslow's.
Drops hierarchy. Gosh, I have a better one. I think if I go cosmic, shoot.
Steve, are you still hearing echo? Are you still hearing
No,
yourself when
I
you're?
stopped hearing the echo. It might have been between you and Ann.
I think, yeah, maybe with Anne, or sometimes Zoom takes some time to cancel noise because it is like artificial intelligence or something like that. So
Okay.
it doesn't work right away. It has to wait for a couple of minutes sometimes.
This one was 22, and this one was done in.
Richard, I have taken notes on the quote, universe is all that is in me and me. What book
Right.
and what page, where is that quote from?
It's from this book we're reading, and
What's the title?
it's called A Fuller Explanation.
Yeah,
And
if you look up on the web, Bucky verse, Bucky, and then verse, Verse, you will
Mm-hmm.
find a new website that has almost all of the books that he's ever written and books that others have written, including this one, available to you in digital form.
Oh my.
okay, I'm not doing a very good job of pulling things up. I, in fact, put some stuff on my external drive. And
Well, just for fun, you do a search for Bucky verse and see what comes up.
okay. Okay, I found it here. Here is this. We'll let that load up. While it's loading up, I'll do that search for. There we go. Okay, this is his cosmic hierarchy. This shows the little, in green, I've circled the little me symbol together with his fullerene, which is cosmic integrity, which is the top thing. And this is another symbol he uses for cosmic integrity, which is the bow tie or the yin yang symbol or the two dots in the circle. And it starts off with 38 different cosmic, comprehensively embracing and permeating generalizations of generalization equals G over N, or to the nth power.
Generalizations of generalizations.
Yeah.
Man.
He goes through each part. So this is all broken out, and we did a whole series on this in our synergetics thing. So this is all part of, I don't know, this is a paper I did. So I'll make sure that this goes out to everybody along with just the 18 me's, okay? And then you requested, Richard, that I do a search for what?
Bucky verse, all one word.
Okay. Buckyverse.org.
Yeah. You can see a list of Bucky's books.
Yeah, in fact, I saw the list there and I didn't click on it.
Well, there on the left, though, you can see that all of the books, and then down further, there's books that other people have written. And
Cool.
there's a digital copy of every one of those.
Oh, wow, wonderful.
Man, people love Bucky if they're doing this kind of stuff, like text manuscripts, latex manuscripts.
So scroll down a little bit further.
Markdown, man, we can do a lot of stuff with Markdown.
Yeah, there it is. There's Bucky related books, and then a fuller explanation is right
That's
at
the
the
one we're
top.
reading out of today. And if you want that quote,
click on it and see what happens.
okay. And if you want that quote, it's on page, it's on page.
Depends which edition you have on. For me, it's on page 11 of the second edition.
Okay, it's on page 14 of the edition I have in my hand. Okay, we'll see what there we go. This is showing me an index of fuller, oh, there's the index of fuller explanation.
And on the left again, you see the preface and notes to readers and preface to 1992. Oh, yeah, there it is.
Okay, good. Yeah, notes to readers, and now we're reading down in return to modality. Modelability is the section we're reading right now.
Oh man, so you can have that in the web version. Can you share that link in the chat, please, for to that chapter that we read?
I'll be glad to do it. And if we want to, I'll be doing that while we continue to read. If somebody else wants to read, I'll do that.
I love the logo, Buckyverse, and there's a logo with a small tetrahedron.
Yeah.
No, awesome. Thank you for sharing this, Richard. This is great. What page are we reading right now?
We're on page
42?
no, not at all. We're like page 11 or 12.
11 or 12?
Let's see here. My page in my book, we're on page 14, and I think in Richard's book, he's on page 11.
Also, different editorials. That's why.
Different editions, yeah.
The editions. Thank you.
I've got that link, and I'm going to put it in the chat right now.
Please, yeah.
There it is. Buckyverse. And then I think what I'll do, just to support you, I will go ahead and put the fuller explanation book link just below it. That's the book we're reading right now. And let's continue to read.
Oh, one thing before resuming. Generalizations of generalizations, it's equals to GG square, GG to the n.
GG to the n. GG to the n.
Okay, thank you.
And that was just his code. Generalizations of generalizations, that's just his GG. And he puts the nth on there to indicate that it's the entire universe. So it'll fractal up and down.
Wow. Entire universe in that equation?
Yeah, he starts with cosmic infinity and ends up with 18 me's. So I guess there's 38 versions of that.
Are you kidding me? The
No.
whole universe in this?
Yeah.
Man, like that's very ambitious to put the universe in a single equation, don't you think so?
Yeah. And that's Bucky. He's quite ambitious.
Describes the whole universe. Oh my God. Okay.
I would like to know. Oh, here it is.
Why do you say that it describes the whole universe? Because it expands to
this is the cosmic hierarchy of comprehensively embracing and permeating. So they embrace each other and they permeate each other. Generalizations of generalizations. GG over n.
Okay.
Or GG to the nth power. And he breaks it into 38 different categories.
Wow.
Starting with cosmic integrity, and maintains that you and I are cosmic integrity, which goes right back to this quote: universe is all that isn't me and me. In other words, universe is all that isn't me and universe is all that is me, is how I would read that.
And that's a perfect quote to put in a t-shirt.
Yeah.
Don't you think so? I would like to give away t-shirts with that phrase printed to all of the group, you know, like to you, to Steve, to Anne, to Joe. We should print out some of those.
Cool. Richard, do you want to continue reading? I don't remember how far down you got, but I think right there is where you are, but maybe not. Oop, you're muted.
Yeah. But Fuller would never leave it at that. He is indefatigably thorough. Einstein revolutionized our understanding of universe, explains Fuller. Prior to his relativity theory, we could think in terms of a single frame, simultaneously complete picture, unimaginably vast, but still simultaneously at any given moment. This understanding must now be replaced by a, in quotations, scenario concept. Universe is the aggregate of all humanity's consciously apprehended and communicated non-simultaneous and only partially overlapping experiences.
You know, 3 years ago, I wouldn't understand. I wouldn't understand more than 2 words of that, but I actually understand exactly what that is saying.
Don't be too hard on yourself. You understood more than 2 words.
I don't think so. Universe is an aggregate. It's an aggregate of all of humanity's consciously apprehended experience
Apprehended experience.
and
I'm confused again
communicate.
with apprehended. Apprehended isn't the opposite of comprehensive?
No, apprehended means to perceive, maybe one good word. In
To
fact, I have to
grasp.
tell you, you got to look at the etymology of that word and figure out what because he talks about apprehension and he talks
Yeah.
about there are 2 words, aren't there, Richard? Apprehension and comprehension. And so you look you look at the etymology of those 2 words, and he chooses apprehension, which means to grasp, to apprehend,
Right.
to grasp. So all of humanity consciously grasped and communicated non-simultaneously. Non-simultaneous. In other words, your experience is not simultaneous with mine, or with Einstein, or with Descartes. But he wrote it down. You write yours down. We talk. We communicate. And it's only partially overlapping. So your experience partially overlaps with mine with Richard, Richard's with Descartes. So the universe is the aggregate of humanity's consciously apprehended and communicated non-simultaneous and only partially overlapping experiences. Kind of like each of us are Venn diagrams.
Right.
And we lap at some point.
Oh
Cool.
man, you just gave me an idea. I was thinking the other time.
I didn't give you an idea. Bucky did.
No, but you were reading Bucky, so that's why I believe it's you.
Richard, I keep interrupting you. Do you want to continue or do you want to continue to, we're going to have feedback. We're going to have takeaways here in just a second.
Oh, sure. If you want to continue, sure. I'm going to take notes on this takeaway.
Good.
Venn
Yeah,
how do you write? Do you spell Venn? Venn diagrams?
just to expand a little bit on only partially overlapping experiences and the Venn diagram idea. This is what came out of one of our earlier discussions, that the overlapping of 2 or more circles, I now understand as being representative of vectors between 2 circles, and so that's something that I picked up out of earlier readings. Anyway, he willingly dissects his own long-winded definition. To Fuller, aggregate implies a complex that cannot be comprehended in totality at only one moment. Consciousness means awareness of otherness.
Yeah, that's profound.
Which is another, going back to one of his other expressions that says, in order for self to exist, there has to be awareness. And in order for awareness to exist, there has to be otherness.
Yeah.
And when I reverse that, it tells me that if there's no otherness, there's no awareness. And if there's no awareness, there can be no self.
Yeah.
So that again feeds into the idea that unity is not one, it's plural, minimum 2. It has to be self and otherness.
Yep. I think of other as a mirror. If I think of my dog or my cat walking in front of the mirror and jumping up and going, what the hell is that? And if it weren't for me seeing you, I would have no idea who I am.
Yeah. And otherness, as from our reading tonight, I mean, otherness is another way of describing all that isn't me.
Right.
So there's me and otherness
And everything else, yeah.
that makes up universe.
Want to continue? We're almost done.
Yeah. Events of universe are instead are we partially overlapping, like generations. My lifetime overlaps my grandmother's, and hers overlaps the life of her grandmother, but I was born long after the deaths of both my great and great grandmothers. Such are the events of universe. Every experience overlaps some, but not all other experiences. Yeah. So there's a vector connection between all of these. Another facet of the scenario concept centers on the misconception of the environment as a static whole. For instance, looking out at a distant star, it's all too easy to think we are seeing it just as it is at that moment, while in reality, that particular star is so far away that its light takes 100 years to reach us. What we are actually looking at is a live show taking place 100 years ago. We are seeing an event that occurred before we were born, where universe is the integral or sum total of all experience. It cannot be unitarily conceived, but as thus defined, it's all inclusive. You cannot get out of universe.
Yeah.
Fuller's definition avoids imparting a sense of thingness, part of his effort to encourage us to think in terms of pure principle. Universe is energy and thought all knotted together. There's another way of looking at mesh.
Yeah.
By incredibly complicated webs of relationships, vectors of relationships. It's ultimately impossible to separate the physical and the metaphysical. Both are experience. The scientific principles that govern the interactions of energy events as timeless statements of truth are themselves metaphysical. The line therefore becomes ever more difficult to draw. This is why Fuller's definition depends upon consciousness. Our awareness of energy events defines their existence. We cannot go beyond the limits set by our understanding. So finally, Fuller assures us that the definition is complete. People say to me, I think you have left something out of your definition of universe. That statement becomes part of my experience, but never will anyone disprove my working hypothesis because it will take experimental proof to satisfy me, and the experiment will always be part of the experience of my definition, ergo included.
Beautiful. At the top, Richard, we'll finish it off. Oh, you muted, Richard. If you'll start again, somehow your button clicked.
Yeah. He elaborates in a 1975 videotape lecture entitled Everything I Know. Someone might ask, what about dreams? I think you left that out. And I reply, no, for that is part of your experience. He seems to have all the angles covered.
Yeah. We'll pause there, and next week we'll pick up right there. And we're going to highlight that. There we go.
Can you go back a little bit?
Can I go back to what?
Can you scroll back a little bit where it says you cannot go out of universe?
Yeah.
please.
I'm going to do that right now. I've got to let this thing think for a minute. And here we go. You cannot go out of universe.
Why is he not using out of the universe, not
Well,
only
he
universe?
explains that up above. She explains that up
Yeah,
because
I know that, but I don't remember
the
the
universe points to a particular universe of other possible universes. And since there are no other possible universes, universe.
Oh my God. Okay, yeah. Thank
It's
you. Thank you.
English people and Canadians say, "Did you go to hospital? Did you go to holiday?" Yeah, we don't do that in America. We say, "Did you go to the hospital? Did you go to the university?" So he became very British then when he did that. And I wanted to take 1 minute here and show you, I mean, just some people listening to this recording may not know what a Venn diagram is. So let's just show up some examples of Venn diagrams. Here are some Venn diagrams. They're not very complicated. Let me switch over to images here. And here's an example of 3. We see a bunch of examples of 2. Here we go. But in Bucky's experience, everything would be partially overlapping. And so it would be, you know, here we go. Here's a Venn diagram right here. In fact, this looks very much like a hypergraph.
Yeah, put that bigger,
This
please.
is kind of like a hypergraph because there are all these points connecting to all these points.
God, oh man, that's so beautiful.
7-set
So
Venn diagram.
what I was thinking is that God is a really big circle in that connects us all. Like it's like the unifier, you know?
Yep.
You-
In fact,
Everyone has a soul, you know?
yeah, there are legitimate philosophies that say, in fact, that each of us are a part of God and that
Mm-hmm.
altogether we are God.
Uh-huh.
And I think Bucky would agree with that. Altogether, we are universe. Altogether, every human being that's ever lived is universe. I love this. This is a 7.
Uh-huh.
This is a 7. How do they say this? This is beautiful. Oh, anyway, I'm going to say a 7 something then, and I'll correct the title letter, and I'll put this in the diagram.
Where are they getting 7 set?
I don't know. Let's take a look at what it says here. The award-winning, powerful Thinkorswim trading platforms. Oh, there's an ad. A Venn diagram is supposed to show all logical combinations of predetermined number of sets. The most common ones are 1, 2, and 3 set Venn diagrams. A 1 set would be a circle. Possible combinations are null and 1. In a 2 set, there would be 2 partially overlapping circles. The possible combinations are null, 1, and 2, and 1 plus 2. In a 3 set, you would have 3 circles and a combinations of null, 1, 2, 3, 1 plus 2, 1 plus 3, 2 plus 3, 1, 2, 1 plus 2 plus 3. As you go beyond 3 sets, the shapes must become more and more complex in order to have space for every single possible combination. Therefore,
Yeah.
it is a great achievement to make such diagrams rationally symmetrical, as Venn himself put it, symmetrical figures elegant in themselves. Here is a 7-set diagram where there are 128 possible combinations, including null.
Okay, now let's test that for a
Yeah,
moment.
test it with n squared minus n.
Yeah. And so n squared is set if 7's the number, is 7 times 7 is 49.
Minus
minus 7 is 42. Divided by 2 is 21.
Yeah, but if you have 128 possible combinations, it'd be 128 squared over minus 128 over 2, right?
No, because the 128 possible combinations to me is 128 possible interactions, vector connections. So it'll be interesting to see where that number 128 comes from, and it might not come from 7.
That's right.
Because on the other one, you see, when you take 3 in a 3 set, again, if I used n squared minus n over 2, then I get 3 times 3 is 9 minus 3 is 6. Divided by 2 is 3, and a triangle tells you that there's 3 interconnections. But he actually expresses that differently. He says, and the combinations are null, 1, 2, 3, and then so he's actually 1, 2, 3 is a node, 1 and 2, 1 and 3, 2 and 3, 1 plus 2 plus 3, 1, 2, 3, 4.
It's like counting the number of intersections, like the overlaps.
Yeah, well, that's
So
why I'm saying that the overlap to me equates to vectors, and I pull them apart and put vectors in between to give me the sense of the overlap. But if I took 3 and did n squared minus n without dividing by 2, then I get 6 minus 3, or 9 minus 3. Yeah, 9 minus 3 is 6, so I get 6. Anyway, I'd like to figure that out, because that 7 may be offsetting. It may be the wrong number that I'm working with. But if we actually, I'm going to try that, just to take the Venn diagram of 3 or even 4 and relate it to his text.
yeah, because this becomes challenging to draw because you need more space. If you want, when you have 3 circles, or 3, how do you call the circles? The 3 groups, or 3 what? Three bend circles. Let's call it bend circles. So if you want to have 4, well, you need more space. If you want to map 5, now you need more space to show all of the 5 different the 5 different circles combining. And then 6 and 7 look all over the space that is needed. It's actually like a map. Like I will need to ask Steve to zoom in to see the smallest intersections, but if not, like if you do it with 8, now you need a lot more space, a lot more superficial area. I don't know how would you do vectors with this, like
Well,
is it possible?
he's actually counting the circles, and he's counting the 3 in between them, and then he's counting all 3 together, 1 plus 2 plus 3. Anyway, there must be some way of understanding where he got 28 out of a 7-step, or what is it called? 7-set Venn.
28 what? 28 intersections?
Well, he's going way beyond the notion of a minimum number of overlaps.
Yeah.
That's probably the difference.
And I think he's being arbitrary in his overlaps in order to make sure that they are none are concentric.
What is
Yeah.
concentric?
Yeah.
They're
They're
none
not
are concentric.
circle.
In other words, there are no two Venn figures that have the same nodes. And maybe
What
he
do
used a computer that actually calculated the appropriate number of unlike guys, you know?
But these are the minimum overlaps, right? The minimum overlaps. There can be more overlaps. So for example, if we do a Venn diagram with the four of us, Steve, no, three of us, Steve, Richard, and me, then you don't have only 1+2, 1+3, 1+2+3. Like you will get a lot more stuff. Like we are all men, we are all using glasses right now, we all have hair, we all like music somehow. But now what kind of music do we all share together? Which one only Steve likes? Maybe Steve and Richard like this kind of music, Steven and me like this other kind of music. So if you start adding and adding all of the overlaps, that's infinite, man. Like, don't you think so?
Oh yeah, so this is the whole thing in terms of using a minimum number
Overlap.
and a maximum or an optimum, and the way you've just described it, there can be no maximum because you would keep adding on the kinds of overlapping that you've just described, and so it just
Yeah,
becomes more and more complex. Yeah.
correct. I don't see why that will have a limit. Like the universe will be the limit.
There are some really good examples here of different kinds of Venn diagrams.
Yeah.
Is there anything
Can,
about a Venn diagram formula?
can you open the one with four examples, like in the right hand, that has four Venn diagrams in one single image?
Hang on, I'm gonna just grab a picture of this, all of this for a second.
And you're going to print it?
I'm gonna put it on this page, yeah. So this will be page 2 of this thing.
Okay, how is time looking? I'm looking at the clock. We are already
Yeah, it's time to
30.
go, but we finished the section, so I regard us as heroes, and it is time to go.
Okay.
So,
Yeah.
and I've got the link right there to get to this page, so that's a wonderful thing, and I will save it and share it, and let's do our takeaways right now. Okay, Julian, how are you feeling, and what's your takeaway tonight?
Why do you start with me? I was the last one to join.
Okay, good. Then you'll be the last one in. Richard, how are you feeling? And you get to go second, Julian. Big break. Richard, how are you feeling? How are you feeling? What's your takeaway?
Well, I'm feeling very good. Of course, I'm very talking about overlaps. Extremely glad that Anne was be able to overlap for part of it, and Julian was able to overlap so that we always had a minimum of 3 and sometimes 4. But this particular kind of reading that we've been going through has really sparked my interest in whether or not the overlapping sort of Venn diagram circles are equated from my perspective to the energy event, i.e. a circle, and the vectors that connect them. And so my experience now is that instead of drawing 3 overlapping Venn diagram circles, or I could do that as well, but then in order to see the vectors between them, I then pull the circles out so I can then draw a line, if you want, between them. And that way I can visibly see the formula n squared minus n, either divided by 2 or not. So it becomes as I've got 3 corners, 3 energy events, and I square them. 3 times 3 is 9, and then I minus the n, which is 3. I get 6. And if I divide by 2, I get 3. And so I can see 3 connections between those 3 circles. But that's just a static connection. If I don't divide by 2, then it's an interaction between each of the twosomes. And so the 3 interconnects then become 6. And then if I were to do what Julia was just talking about and adding on different dimensions that each one of us might have, then of course the vector connectors become start to multiply and become quite complex. And eventually, even with just the 3 of us, you would end up seeing a mesh of interconnected vectors. And the idea of a messy network or an entanglement between the 3 of us would become very real and very understandable. And the only way I can do that is if I have a way of modeling all the different interconnections, whether it's a minimum of 3 or a multiple of the kinds of added additions that Julio gave me. And that to me is what I think Fuller is getting at around the importance of modeling, having models, in order for us to understand and see the invisible. We have to create a kind of a physical manifestation of that invisibility. And that's when his argument and others is that we have to be willing to use geometric modeling in order to help us appreciate all of the invisible in addition to all that's visible. So, and that's why, again, he talks about generalized principles. So a tetrahedron is just a generalized principle of energy events connected by a minimum of 6 vectors, and they can be short, small, tiny vectors, or they can be long, stretched out vectors. And it can be any size. It can be very little or it can be very big. So it's really a generalized principle. But in order to understand that, I have to put it into some kind of physical model in order to represent that reality of invisibility. So this is all individual learning that I'm taking away from rereading or revisiting the Fuller explanation book after many years of
How many times have you read that?
Oh, well, I used it years ago with students. I introduced students to this way of thinking.
How many students?
Oh, it was, you know, several hundred over a number of years, but
So several hundred.
and they all
That's
hated it.
incredible.
And they all hated it. Julian, did you hear that?
Well,
Well, I'll tell you one story. I had an engineering student who transferred from his faculty of engineering over to my faculty of social studies or social work. And when I started talking about Fuller and this book, and doing some of the things that we have discussed tonight, at
Yeah.
one point he put up his hand and said, I don't understand this. I'm actually going to quit and go back to engineering where it's easier.
Comprehensive.
So
Totally comprehensible to say that.
I took that as a backhanded compliment.
No, but like if you ask me, the moment that I started these bookies calls, um, like the first 2 or 3 calls, I got like 50% or no, I believe less, like 20%. Like 20% of the conversations is what I was understanding. And English is not my my mother language, so I was also conflicting with, hey, I'm trying to understand, but I'm not able to talk with you and to pronunciate. And my words in English were like, I don't know this word, I don't know this word, I don't know this word. So all of this time, how many, more than 1 year, how much I have been on this still? Do you remember? I believe like 2 years maybe.
Yeah.
But in those 2 years or whatever the time is, um, I have elaborated a lot of more and a lot of more. Like this is not something that you see one time and oh, I get it. It is this and this and this. No, you have to read it and read it and read again and talk about it and pull a piece of paper. Like all of those, like Steve is really good teacher, like he is really good going step by step and letting you know, like, are you following me until here? No, okay, let's step back, and he's really good doing that. So I can see why your students were complaining about this. Like, if you do this along mathematics or financials or whatever, like, I probably won't be fan of that.
I want to tell another story on Richard. He told this a while ago. He was one of his classes. He was well, all of his classes. He used everybody to. He used the tetrahedron as his basis for a conversation around social issues, particularly around suicide, but around all social issues and around sociological relationships. I hope correct me if I'm wrong, Richard, but he was one particular girl was just totally frustrated and just hated the whole thing, and she uh, she left the class really frustrated, and then went home for Christmas vacation. And when she got home for Christmas vacation, they said, "Okay, we're going to build Christmas tree decorations here," and she had to build a pile of tetrahedrons to hang on the tree. Did I get that story right, Richard?
Oh yeah, yeah.
Yeah.
She was so frustrated, and she used the language of fed up with this tetrahedron talk. And her sister said, "Oh well, we're going to go down to the church, and you can do occupational therapy all afternoon. You don't have to do anything that is thinking about those tetrahedrons." And what they were making was stuffed tetrahedron Christmas tree hangings. And so she had to spend all day making tetrahedrons. And when she came back to university in January, she had two of them in her hand, and she came to my office, opened the door, and just threw them at me and said, "You won't believe what I had to do when I went home." It was like, these things are now stuck in my head and I can't get rid of them. And,
Yeah.
and even my sister sort of drew me into the damn things. Yeah, yeah,
Okay.
right on.
All right.
Great
So
story.
should I go next? Or do you want to go before me, Steve?
Okay,
No,
so
you're the host. You're the last always.
yeah, I'm the last guy.
Okay. You like to be the last guy, right?
Yeah.
So takeaways. Look, even 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 I was joining late, like really late. Sorry for that. Um, I got some serious takeaways. You cannot go out of universe, not the universe, of universe. So that explains that we don't have multiple universes. And I already shared with you the overlap that everyone has with God. Like all of us has an overlap with God. Um, then the no static scenario, like we are all Venn diagrams that are moving constantly. It's such an amazing figure. And another takeaway that I wanted to share with you, it's a takeaway from this call, but also something that I was thinking just the moment before this call. And I was really happy um, with this discovery because this is a study group, right? This is a Bucky study group. I'm
Yeah.
correct? You call it like that, or you call it in a different way?
We're studying, it's a Bucky study group on this particular book called Fuller Explanation, right?
Yeah.
What do you mean
Yeah,
more
yeah.
specifically?
No, I just was checking if that's the name of the group because probably you were doing another name. So I have not been joining these calls like so long ago, and I was thinking, hey, it's because I don't have time, right? Yeah, I'm busy doing something else or something familiar, or like Saturday nights for me are like very social and that stuff. Um, but I was thinking this because I don't have time. And now I'm facing a challenge in my job because I I'm working 4 hours. Like I have an hourly rate. I have never worked that way before. So I have an hourly rate. So if I log less hours, I get paid less. And that doesn't happen before because I was working free time and they were paying me for the whole 8 hours, you know? So that is to say that I was really happy to see that I'm doing less hours and I'm doing that free and having more free time. And I'm not using that free time. And now I realize, hey, I can use that free time to study more. I have not been studying since long ago, like taking some courses, taking some lectures, reading a book, doing some academic program or lecture or something like doing academic stuff, learning some stuff is something that I have not been doing most recently because lack of time. And now that I have time, is well like, oh, I now have time to do all of this. So, if this works, it means that I probably can join more of these calls. So that would be good. So let's see. I hope that my Venn diagram that is overlapping with you is going to grow bigger. And let's see how that goes. Um, now, now that you told me, Richard, about you giving a lecture to 100 students about Buki, and they were all like not good with that, and not good feedback. Now you're inspiring me that I can tell Raffers that he and I joins and take a chance at my university, at my alma mater, and see if we can make a lecture of this. You know, there are some courses that are like optional, like we call it CBUs, like basic cycle union dino. Are these kind of courses that you can take philosophy, you can do architecture, arts, and you're an engineer, and so you're
We
not
call them
supposed to do that, but
we call them electorate courses. They're what's
electoral courses, okay.
yeah.
Yeah, something like that. Carpentry, whatever, music. For example, I did experimental music. I love that classes. But the thing is, at the end of the day, I think that will get me closer to the academic world and give it a try to do a lecture. You know, like I have never thought of that. So you're inspiring me to me, Richard. I will reach out to Raffers to see if that rings a bell to him,
Hmm.
maybe. We don't know. But yeah, those are my takeaways. Thank you guys. Thank you guys. I love seeing you again, and I really enjoy seeing Anne again. If she sees the recording, uh, I really would like to see her. I would like to keep working with her in the other project, but whatever. That's on hold right now. So, Steve, how do you feel? What do you take away from this
Well,
uh,
I'm inspired.
to the group call tonight?
Yeah, I'm inspired by everybody on the call, and there's always an inspiration. And I hope she has a chance to listen to this because I think it's been freaking amazing. And and I got to tell you, Julian, I've been listening to Eric Schmidt, who is the former chairman of CEO CEO, former CEO of Google, and he left Google and he started working with the U.S. Department of Defense. I've been listening to a bunch of stuff about AI from the All In podcast. These are the guys who started PayPal and Uber with Elon Musk and other guys. And I've been listening, particularly, I heard one from a Stanford University professor on how
Sorry,
what? I'll send you a
what
bunch of
was the name of the ex-Google CEO?
the name of the what?
Of the CEO, the
His name is
ex-Google.
Eric Schmidt, but it's going to be a hard one to find because they took it off. He is Stanford had it on their site. Google was all excited about it, but he ragged on Google and they took it down, and it does not come up in rotations. So I've got to send you the Eric Schmidt one. I'm going to send you out the education one. Listen, it's a perfect time not to have a job. Because if you're spending your time full time working on somebody else's project, you are going nowhere, dude. Your idea to start working on experimental music and to do weird things and to get rockers involved and start treating your own course.
Yeah, yeah.
This is the time to follow your bliss. Do you know the story of Steve Jobs in calligraphy? Steve
No.
Jobs in
Yes. Steve
all
Jobs
right.
took some calligraphy classes,
He
and that
quit
was
school. He quit school because it was irrelevant to him. And he didn't want to spend his mother's money, his mother and father's, his adoptive mother and father's money. So he quit school and he just attended a course on calligraphy. It's called audit. He just audited a course on calligraphy and it ended up changing the world. Dude, follow your bliss and change the world. Okay, good. Listen, you guys have been so inspiring today that I have to share this one final big takeaway. It's so exciting to me. So, you guys saw that I put together this page that's going to be attached to the event thing. This is the rationally symmetrical 7-set Venn diagram right here with a little explanation. I took some of the other pictures here. Here's the link to get to this page. Okay. And then, but I had another epiphany and I wanted to share this with you. This is so freaking mind-boggling. Here we go. So I thought, well, what if we took the Venn diagram and we shoved the circles of irrelevancy on it? And it looked like this.
what is that? The circles of irrelevancy? What is that?
Yeah, the circles of irrelevancy. This is Bucky's diagram of consciousness, of conceptual reality for human beings. And if you look at the center of these diagrams is it's wrong colored. They should be colored the blue color here, but in the center is stuff that's too small for people to see. The next circle is stuff that's tantalizingly almost too small to see, but not quite relevant. And then the blue circle with the red diagram is where everybody sits in their consciousness. And then things get tantalizingly almost relevant, but they're too damn big to really put into scale. And then you get things that are macro, just unconceivable. And so there's an infinite circle going around each one of these three circles. And what I did was I stacked the three circles on top of each other. Then I put this Venn thing in the middle of it to show the overlap. So
Man, that's you see why I say that your book is very graphical? Like
yeah.
you need to be you need a graphic designer for this. Like you need a handy person that can really illustrate professionally like this. This is amazing, Steve.
Yeah.
I
Well,
have a
thank you.
question. I have a question.
Okay.
Where is the soul?
What?
If those are three people, where is the soul? Your soul.
My
The
book?
no. In those three circles,
Oh,
in
yeah.
those three circles,
Oh, where is the
and that
human soul?
bottom, you were talking about an inner self, isn't it? So where is
No,
the soul?
I wasn't. It kind of looks like an inner soul, but what it really is the set of non-conceptual finite withinness that is too small or too frequent to calibrate. And if it's too small and too frequent to calibrate the human consciousness, it isn't part of our reality. So in other words, the little bacteria that are in your body that are keeping you alive, they're non-conceptual, they're finite, but they're within, and they're not relevant. You know, we had to get microscopes and say, oh, well, look at these little bugs inside of us, make us sick and make us well,
Yeah.
right? So this is
Yeah.
non-conceptual, too small, too frequent. Then we have stuff that's right on the edge. Oh, I almost grasped that. And this blue circle is the conceptually finite. This is tunably synchronous, approximate simultaneity. In other words, this is what I perceive as my conscious reality. Then outside of that is the twilight zone of almost relevant because it's too big and too infrequent to be calibrated and create any relevancy. And then outside of that is macro irrelevant. Let me show you the actual diagrams from Bucky. Let's see here. I'm going to go up here and say, I had to look quickly and find it, but name circles. There we go. And here is the page. This is Bucky's page right here. And then I took Bucky's page and I started to colorize it in order to create some meaning for me. So here is Bucky's page right here. I'll do the single page view. And this is what he says: non-conceptual finite withoutness, non-simultaneously, non-synchronously timeable, tunable. Yeah, it's too big and too infrequent to tune into it. And then we have the twilight zone of almost relevant because it's just on the edge. And then we have conceptually finite. Then we go into micro. This is micro. This is macro. These are the circles of irrelevancy that he talks about in the Synergetics book. And so then I kind of did a study on them. I colorized them. And then I started analyzing stuff and putting things together. And I put that together to come up with this little figure. Oh, there's more of a, and this is the final thing I did. I am here. I'm in the middle of this. Everything inside of this is too small to, gets smaller and smaller and smaller until it's non-conceptual. And then everything outside of here gets bigger and bigger and bigger until it's non-conceptual. And then I took this circle and stuck it on top of the Venn diagram. And then I took this little segment of the Venn diagram and stuck it into these circles to kind of show the overlap.
Yeah.
I'll send you guys out this. Okay.
Well, the circles of
Yeah, that's interesting. That's
relevancy
interesting.
is what I use to visualize Fuller's idea. Every morning you wake up and you start with the universe, and then you travel through all of those tunabilities or tune-out abilities, all the way down to the specific thing that's relevant right now. I use the example of brushing your teeth. If I zoom in too far and try and understand, you know, what makes up the fiber of the toothbrush and all that kind of stuff, then that's too micro, it's not relevant. And probably the only time it could become relevant is one of those brushes sort of got pulled out and got stuck in my tooth and I couldn't get it out.
Perfect analogy.
Then all of a sudden I would tune into that micro sort of
Right.
fiber of the toothbrush.
Suddenly the micro element of the toothbrush becomes relevant.
Yeah.
Because it's stuck in my damn tooth, right? I'm saying, what is that thing?
Yeah.
Yeah.
And And so that when people say, when I try to explain the difference between part to whole, and say that Fuller says start with the whole, the universe, and travel into what's tunable. And in many cases, it comes all the way down into a thought that can be tunable, and anything that is troubling that thought is tune-outable. So you actually get rid of a whole bunch of things that might be interfering with that thought, because the thought then becomes the relevant tunability that you want to be paying attention to. So I love that diagram in terms of starting way out at that big ring and then coming all the way into what's relevant at a given moment. And that's where I use the example that the moon phases, for the most part in a month, are irrelevant. They're way out there. They've got nothing to do with what I'm doing today, except the full moon, as an example, all of a sudden turns into being relevant because it's affecting what's going on around me, either in my work life or my own personal life. And so now I have to tune into that macro thing that for 29 days of the year of the month is irrelevant.
And inversely is true when the moon is in some variable phase of getting larger or smaller, it's irrelevant. But as soon as it's a full moon, or as soon as it's a new moon and it's not there, and I need my damn flashlight to walk outside and put the trash, suddenly the fact that the moon has phases becomes very relevant.
Yes.
Yeah. Very cool. Well, so I sure appreciate being able to share. My gosh, it's wonderful. Even I get more takeaways after my takeaways. I'm really gonna look at this using a tetrahedron as a. You need to mute, Julian, because it's using the tetrahedron. Try to find a tetrahedron model to explain things, lines, or things or events, vectors, continuous plane, and observer. That's what I'm seeing. I'm seeing lines are vectors, and things are energy events. The observer is required, and there's all energy that's even not observed. Then there are things that are observed, events that are observed, and then there's the observer. So there's 4 elements. Anyway, I'm playing with it to see what the hell. It's very exciting, because I think your vision about using the tetrahedron to teach principles in sociology is profound, because it demands that I start looking where I wasn't looking before, and that which was not relevant becomes relevant, because I'm looking for something else to put in there. And I say, well, this is something else, and then we can agree how relevant that is. We say, well, we're going to put that in or not. Really cool.
That is something that you should take a look again in the transcript tomorrow. If you can scroll to this point of the call and take what you just said and copy and paste it and send it in an email to everyone in the Bucky's call, that's going to be awesome.
Well, cool. Well, I'm really grateful for this group. It wouldn't happen without the synergy that's here. So thank Bucky for synergetics, and thank you for the synergy.
True. Thank you all too.
Golly, and we started a little bit after the appointed time, but we're way beyond the appointed time. Richard, did you have something to say? If you do, unmute. Okay, good deal. Bye, everybody.
Bye, Stephen. Bye, Richard.